market price as everyone else when you're selling, producing and selling an apple. So let me just start laying this out. So I'm going to do the second one, perfect competition scenario, because that's the easiest. And say we're going to do 0. I'm just going to do total cost on here because I don't have room, but on the sheet, you will see fixed cost. So this is kind of like a profit and loss statement. It's like a accounting for a company. And fixed cost, it's like the lights, utilities. Just assume that's like the same amount every month. So you are spending every month. So you do have to make some profit every month to cover those fixed costs. And then variable costs, VC, is like the supplies or the raw materials that go up every time you make more. So it varies according to your quantity. So I'm going to do total cost. I'm not going to worry right now about average variable cost or anything. Just total cost. If we make 0, say our total cost is $5 because we have to pay rent no matter how much we make. So there's always a fixed cost there. If we make 1, we do have a variable cost of say $2. So, well, I'll just say $7 there. So it costs us to make $7 to make 1. If we made 2, our cost is 17. If we made 3, 21. I'm going to go up to, let's see, 7 or maybe 8. Oh, I'm not going to go through all these numbers. Let me just do the important ones. 37, 39. Okay, so remember these are lookup numbers. If we made 2, our total cost for that month would be 17 and so forth. So it's not like over the course of the month we're accumulating costs. It's like if we made these quantities, our total cost would be so and so. How do we get that? Well, it's a given. We need to analyze, well, how much was spent in making those kind of things. Theoretically, I mean, it should cost the same to make each one, no matter how much we make, but there's going to be the too many chefs in the kitchen phenomenon, that when we make maybe too little or too many, it's going to cost more for that extra one because there's waste and all that. But also we can get marginal cost. So marginal cost is that extra cost to make that additional unit. So from 0 to, let's see, 0 to 1, we have a marginal cost of $7. If we made 2, that extra unit is going to cost us $10. Wait, what? Wait, something's funny here. Oh, I'm on the wrong graph here. But still, let's see, total cost. Cost 5. Oh, and I have the wrong numbers also. Yeah, I was going off of Monopoly, so make sure we are on perfect competition. Okay, 0, yeah, we're costing 5. To make 1 is 7, to make 2 is 12. Oops, 5. Costs. Okay, 12, 17, 21, 25, 28, 32, 37, 44. Okay, now we can calculate marginal costs. That every time we add another, make another product, it will cost us that much more. So we increase by 7 there, 5, 4, 3.5, 3.1. No, what am I looking at? 725. Okay, I think there's rounding error. This one column didn't have all the decimals, so we don't see exactly what's going on. 4, 5, 7. Okay, so what marginal cost shows us that when we add the extra unit to be made, our costs actually go down. So it's kind of like the chefs in the kitchen. You know, a few more chefs making more product in there was more efficient. You know, it cost us less than if we just made one. So, but at some point, marginal cost seems to go up. To make that 8th product, it's costing us $7 for that extra product to be made. So, you know, we could graph this, and there's price per unit. All of these will be translated, you know, per unit. We're not going to deal with the whole totals. So our marginal cost per unit kind of goes down, and then it goes way up. So there is a part where, you know, it's pretty cheap to make those additional units there. So that's typical of marginal costs. You start building up some efficiency, but then there's too many cooks in the kitchen, and it gets, you know, you shouldn't be packing in that much per hour. You shouldn't be making 8 donuts per hour, because it's costing you more, because there's no room in the kitchen or the factory to do it. So that's the cost we have to deal with. Now let's look at price. So we're going to look at kind of the total profit of this factory. And price is $6 per unit. So I'm actually going to use total revenue first, and then the marginal revenue. So if we made one donut and we sold it for $6, remember, we're in perfect competition. We're stuck at, say, $6 for that product because everyone else is selling it for $6, so we have to sell it for $6. If we made 2 and sold 2, you know, that would be $12. So that's all mathematical. So we can create the marginal revenue for each unit made. So we're at 0, we have no revenue. 0 to 1, we increase by $6. From 1 to 2, we increased by $6. So our marginal revenue is all the same per unit, no matter how much we make. Because, once we have the product, we sell all of them for $6 each. So that's why we have a straight line. This is marginal revenue. Sometimes this is also called Mr. DARP, which is also demand. It's like a demand curve. It's our average revenue, it's price. But you can figure out from kind of running the numbers what you're going to get. You're going to get a straight line no matter how many you make. So the most efficient spot is actually, the place where you will make the most profit is where MR equals MC. Now, this is the cheapest place to make it at the bottom here, but you can still sell more. If you have more to sell, you're accumulating that much more profit, more revenue. So you keep making more per hour until that last unit doesn't exceed the revenue that it brings in. So down here, say it's costing you, say $4, and that unit is bringing $6 in, so that's good. Maybe over here, it's costing you $5, and it's still bringing in $6, so that's good. And here, it's costing you $6, and you're bringing in $6, so that's where you stop. Going past it, your marginal cost might be $7, but if you're only making $6, that unit is going to cost you, a negative, $1. So, it's safe to be down here, but you might as well make more so that it accumulates more profit coming in. And on the sheet, the Excel sheet I did, you can actually see the profit. Profit is highest at 6 units, $11. Now, if we made 7 units, that 7th unit is let's see, is it costing us more? Not a whole lot. It looks like, we're losing because our marginal cost is, it's only $5. Anyway, there's some point where, it'll you'll start losing. So the perfect competition curve is fairly simple. So there's a whole Pearson chapter on that. So the moral to this story is stop here where MR equals MC. You can also run the numbers and actually figure out how, total cost, total revenue, see how much profit you have. On the sheet, the last column, I also have a MR minus MC just to show the contribution of each additional unit. So now the thing with perfect competition industries is that there's no economic profit. Everyone is making it with the very minimal profit needed to run the company. You really have to have a monopoly to charge that extra icing on the cake to make kind of the juicy profit. So, at this point, you can only do as good as everyone else in this industry. You can't really make a killing in this industry because it's a commodity and you're a price taker. Okay, any questions on that scenario? So let's go into monopoly. And this is kind of hard to understand, just graphs that someone else made. You it's a lot better if you can do this all yourself and figure out the each line item and graph it, then you can really see where things came from. Monopoly, you can make a greater profit on. Let's see, where's the highest profit? It's way down at 6. I won't go through all the numbers. I want to talk about price mainly and total marginal revenue. Price, total revenue, marginal revenue. Okay, so with a monopoly, you can charge more and kind of give a discount for if you make more product. So it's basically going to be like this, the price. When you can make more units, per hour or whatever, and sell them all, you can lower the price because it's more efficient. Also, your market, the demanders, consumers will buy more for price. You don't really need to know exactly why, but just know that a monopoly can lower their price when they make more units per hour. That's why it's sloped like that. So it's the same thing as that straight line, but the price does change a lot. You can charge a higher price, especially if you're a monopoly, because you can't get it anywhere else. Now you can't charge an infinitely high price because people buy substitutes. So even iPhones, they can charge a higher price, but there's substitutes for iPhone when the price gets too high. Now, let me show an interesting aspect of this price thing. So say price starts at 11, 10, 5, 10, 9, 5, 9, 8, 5. Okay, so total revenue, 5, 20, 36. There's rounding in here. And so forth. And then if we look at the change in revenue for each bracket here, we will see 5, 9, 5, 8, 5, 7, 5. I mean, you don't have to calculate all these, but what happens when you plot this, it's actually going to be a half slope. So, and this will all be given to you. You will rarely need to figure these kind of things out, but this is how it would be derived, which is kind of weird. The revenue that comes in is a different slope than actually the price. So why is that? Well, it's kind of complicated. It has to do with when you change price, all quantities, all people have to get that price and it has to all readjust. So anyway, just know that marginal revenue is going to be a different slope than price. And you're going to have your marginal cost curve. So say it's like that. So we know how to calculate marginal cost. So we're still, this is a lookup graph for quantity. Remember, this is price per unit. When we start adding quantities, per hour that we're making, our costs will go up. Our price actually goes down. And you're going to look for where MC equals MR again. This sets the quantity of where you should be at. And in this case, I think it's going to be maybe 6. Now you can't stop there. You use this MC equals MR to figure out what price will be. Okay, so that's your magic number. Now there's one more line here to look for, which is average total cost, or ATC. Now we figure average total cost by looking at all the costs and dividing it by the unit. So, it's at 7 ATC is say $6. Average total cost will be a curve just because MC is a curve. Now MC changes quickly because that's each additional unit it's going to change, but ATC is kind of the average of MC. And it might look something like this. I know it's getting kind of complicated here, but try to stay with me here. So at 6 units, or wherever MR equals MC, that's where we analyze. You can ignore everything else. The curves don't matter at this point. We're just looking at the heights of where this all is. And price per unit should be higher than your average cost per unit, because that's your profit. You want to make on average, and the price is going to be, kind of the average of all of them per unit. Price is higher than your average total cost, per unit, you're making a profit there. So that equals profit. It's actually economic profit. So that's a good place to be. So the moral of the story here, first of all, make sure MR equals MC, and then make sure price is greater than ATC. So ATC is kind of your average cost for making that each unit, and your price is, the money coming in that better be higher than that average cost. Don't use MR in these calculations. Price is what you're actually charging in the store. But you need MR to figure out that quantity where it hits MC. So this distance here is our profit. And if you get rid of everything else, because it's so distracting, you're mainly looking at the price, you're looking at average total cost, I mean, you don't really need to look at anything else at this point. And you know, if price is higher than ATC, then we're making a profit. Okay, I know it's complicated. What's the first thing I should re-explain here?
I'm not really sure.
Okay, so let me summarize how to get these curves, where these curves come from. So as a monopoly, price is going to be on a diminishing marginal price. When you make more, you're going to charge less. From price, you can find out your marginal revenue. With each additional unit you're packing into that hour, it's going to change the revenue for each additional one. So the MR is going to be, like that. Technically half the slope of price. You still have your MC. And you know that this is the magic point here to figure out. And we're going to have ATC, our average total cost. Marginal cost only is the cost for that additional unit, but we want to have an average. So we figure out ATC. And you can figure out ATC just by looking at your, fixed costs plus your variable costs, divided by your quantity, just like in a profit and loss statement. And it's on the sheet here too, how it's figured out. So you plot your average total cost, and now remember, where MR equals MC is your magic point. You don't need to look anywhere else at that point. If your price is higher than your average total cost, you're doing good. So that's where to be. And then this segues into what's called monopolistic competition. So what if we weren't doing that good? Well, say you had your monopoly, but after a few years, there's going to be other entrants into the market. Monopolies don't last forever. Other people are going to come in. Your costs might raise, your price will have to come down. And what's going to happen is that your ATC, your costs are going to be lower. Well, really the price comes down, but let me just change ATC here. What can you tell me about our profit at our magic point? Remember what price means. That's the money coming in. Remember what average total cost is. It's, the cost per unit. So this is price per unit, and this is your cost per unit. So if it's here, what's our profit? Price is the same as your average total cost. So you're not making any profit. It's actually considered no economic profit, no icing on the cake. At here, all the expenses are being covered. You're not losing money, but it's nothing special here. So if your costs have hit price, that's, you're doing no better than a perfect competition scenario. You're barely making enough to survive. You're just breaking even at that point. So that's kind of the first thing to look at when you see a graph, like this. So we'll start out with price per unit, marginal revenue. Got to figure out where that magic point where MR equals MC is. Well, this is MR, and if this is MC, well, this is the magic part. Let's just say it's 5. But we can't tell anything right now because we need to figure out where ATC is. So if ATC is here, is this good? All you're doing is comparing price to cost. The height of price is so much and the height of cost is so much, and if they're the same, it's like zero economic profit. So not a great place to be. Now, if ATC was, average total cost was here, what is this saying?
Is it still not good?
Yeah, I mean, costs are way higher than price. So, with each unit is bringing in this much, if you're making, 5 units per hour, but it's costing you a lot more than what you're bringing in. So this is a loss at that point. So, you look for where ATC is in relation to price. So if what we're making, is right here, if price is here, you want your cost to be below that amount. And that's kind of the difference between monopoly and monopolistic competition. Monopolistic competition is kind of like an old monopoly that's lost its edge. And monopolies will eventually, their price will come down and their cost will rise until it's kind of a break-even point. So, it's kind of hard to talk about these things unless you kind of know where these numbers are coming from. And, it's good if you can do it on Excel and actually recreate, this whole thing. Give me another question. What's the next hardest thing on this? So on those graphs, it's complicated if you don't know which line is what. You need to kind of draw on it and show exactly what is what's happening there. So let's go back to perfect competition. Which is easier because the price coming in is the same. So this is PC. So price, no matter how many you make it at one time, you still sell it at the same price because you're a price taker. Everyone's selling it at this price, and there's going to be a marginal cost, and it's going to be at that point. I wonder, let me look at where ATC is. Yeah, I mean, you can graph ATC on this also. And I think it would look like that. See, do you understand what that means? So you're bringing in a certain price, no matter how many units you're making, but at low quantities, per hour, you're not efficient. Your total costs are pretty high, and your marginal costs are not good. And at some point, there's a sweet spot that your costs are down, and then past that, your costs are going to go up. And this means you're break even. So usually in a perfect competition, you can't have ATC below price. That would be ideal, right? If somehow your ATC was down here because you're making all that profit, you're getting that, and it's only costing you that. But it's hard to get there because everyone else, it's a commodity, and it's hard to charge a premium on this product here. So if we go into a monopoly, there's going to be this declining price and the half slope marginal revenue. And you just have to figure out where that sweet spot is by using your marginal cost and figuring out, okay, so it's got to be here. And on paper, you can find, what numbers are closest to each other. Because it's not infinitely small, it's not going to match exactly, but find out where it's closest. This shows you the quantity you should be at. The average total cost should be, below price. Hopefully, it's somewhere up there. That means you're making a profit between here and there, economic profit. As monopolies lose their competition and get less efficient, the price is going to come down relative to ATC, and ATC will probably end up there. And that's break even. So remember, break even in economics is okay because all the costs are being covered, but it's no great investment for new investments to come seek out. It's just the same, an okay running company. Okay, so you just, look at where ATC is. If ATC is higher than price, that means the costs are higher than price. So don't get distracted by all this other curves around it. Once you find your quantity, that's all you need to know. Okay, so I'm not sure how to make this any clearer. I've boiled it down to what I think is the core of it. So I don't know, comments on this? What's the, give me a question here.
I think it makes sense. Like how you explained it, I think it makes sense.
Mm-hmm. It's going to be more clear if you actually take the time and plot it out and try to graph it, and then you can see where it all happens. Let me explain one more thing about well, I wonder if, I'm not sure if it's on the assignments or not, but it has to do with exiting the industry. If a company is losing money, say you're here, you're below the price, there's a loss there. It might sound confusing without the whole context, but I'll just talk about it. If you're covering your fixed costs, you should stay in. Well, I won't get into this right now because I don't think it's going to be a major thing on the assignments there. But this is the core of these output graphs. When you bring up the Excel graph, okay, so let me go to perfect competition first. I did graph the profit here. This is kind of extra. You don't normally do this, but I'm graphing the highest profit point, and that's comes close to where MC equals MR. So in perfect competition graph, the first thing you look at, where does MC equal MR? So it's right there, and that'll give you a quantity of between 7 and 8. I think here it's, if you're stuck with one or the other, I think it's closer to 7, and that's pretty much what you need to know there. On Monopoly, if I can get this up there. First thing to look at on Monopoly is your price. So you see the declining price. Is my cursor, can you see my cursor?
Yes.
What? Hunter, can you see my cursor?
Yes, I can see your cursor.
Okay, good. So that blue line, look for price first. So that's what's going to come in. Price per unit, your revenue per unit. Next, find that MR, marginal revenue, underneath it. It should be the half slope of it. And that's key to finding it where it hits marginal cost. And next, find marginal cost, which is this red line. And you can see it's going to hit marginal revenue right there, around 7. That's where you stay. So everything is going to be related to this 7 area. Next, you look for average total cost, which is this bold dashed line, and you see where it is in relation to your price. So is this good? And why?
Price line is above ATC.
Right. So you're bringing in that revenue per unit, and that unit is costing you less. So there is profit there per unit. So that's good. And this other thin line is just an extra profit line. So profit is maximized around that area. Now, if we go to monopolistic competition, it's pretty much the same thing as Monopoly, although price is lower. And let's just say that costs are the same. Marginal cost, ATC is the same. First of all, we need to identify where marginal cost hits marginal revenue. So we see it's here around 5. And we look at where price and ATC is. So is this good or bad or what?
It's bad, right?
Why?
Wait, no, never mind. No, that's good, right?
Yeah, it's good. Because price is still higher than ATC. But, not by much. It's losing ground. And, this monopolistic competition, almost becomes, it's like a commodity. It's hard for anyone to make a lot of money in this industry here because you just can't charge a whole lot. So it's still okay. If ATC were above price, well, then that's bad. So, all this other stuff around it, you don't need. You just need to focus on that MRMC, and all your stuff is right there. So, hopefully that explained something about these things. There's going to be a lot of assignments on these. There's going to be the specialty tests on Schoology, and then the Pearson will have 3 or 4 assignments, chapters on that. So Any more questions on this?
I don't think so.
This is kind of the last section of microecon. I mean, if there's one thing to know about microecon, it's this stuff, and it can be really confusing because it's so abstract here, but it's really not that hard if you I would try to recreate this at least once just so you can make your own graph. You don't have to do the graph in Excel. You can just plot it manually, but if you can do a graph in Excel, it's going to help you in your nutrition field. You can make graphs of nutrition. So that's what I have for tonight. So email me if you have more questions on this. I mean, it's really hard. I don't know how the other students are going to do this. It really takes more tutoring and explanation on this. But more importantly, it takes your own questioning. How do I do this? And I think you're good at that. You question you want to find out, and you should be mad if you don't know. So try to pursue this. Look through my Excel sheet and see if you can get that done. Okay. All right. Thanks, Hunter.
Bye.
Bye.